for demo time, this time with some questions from R. Howard99. So this was on the video where I was going over how to implement a digital control module. These can be simple or complex, kind of self-contained pieces of code for doing digital control. So bang bang for valves, sequencing, doing valve pulsing for power save modes of valves, all sorts of fun stuff. And he had a couple questions, and I've got answers for both of them now. So we'll start with this one because this was simple. This is fantastic stuff. I'm curious what role the AO channels are fulfilling in this example. And the answer to that is I did not have software variables implemented yet when I was making this training video. So there's these 4 process values here in the middle. I had them configured as analog output channels just because that is something that could be commanded from the GUI, and even outputs continually transmit their current value as telemetry, which just makes them usable in other things that work with channels. One of the really common, not the right word, one of the design pillars I'm trying to follow with this software stack is make everything work with everything else as much as possible. And that's definitely not going to last forever. And there's already a couple of things that are making that a little bit difficult. Like I need to optimize digital inputs more. So I'm going to be specializing some logging and stuff for Boolean data and integer bit packed data to be able to get some more chooch out of my digital input task. That's currently the last man in the race. But yeah, so I demonstrated in this video making bang bang, and then the other question was, oh, and I guess before that, the follow-up to this is I now have software variables. So if we look at that, I have way up top, I have a task I can configure where I can just have channels that are named, and the GUI can command them the same way it commands outputs. But these are just available as channels for other things to grab onto and use as process values and inputs. So spoiler, we'll be looking at doing bang bang control using some of these software variables now, as well as some kind of discrete range control that is being used to slow down fill rates as the ullage decreases in this example. So that was me just using what I already had to be able to do some testing of other features before I needed software variables. Now, the next one, would you be able to implement an Ullage-aware Bang Bang controller with this framework? I mean, anything I have the time to and know what I'm trying to do, probably. The idea is to control multiple pressurization valves based on the current ullage in, let's say, a liquid oxygen tank. Let's say 3 valves, high flow valve, mid flow valve, and a low flow valve. When the tank is empty, all valves come on during the pressure cycle. As the ullage decreases, maybe only the high and mid flow come on, then only the high, then only the mid and low, and finally, when the ullage is smallest, only the low flow valve comes on. The idea is to prevent an overpress situation when you are working with high pressure propellant. The Bang Bang would need to know what the current liquid level in the tank being pressurized is and what its max level is. Sorry for the long-winded question. I love these. Coming up with ideas like, this is going to make my software stack better and more usable for more situations, so bring them on. For anybody that's not aware, what ullage might be. So when you have a vessel containing a liquid, the space above the liquid is ullage. So just what is the empty space in a tank? And when you're talking about cryogenic materials, liquid nitrogen, liquid oxygen, all that sorts of fun stuff that you might be playing with rocket engines, typically that's going to pressurize itself as the fluid boils off inside the tank. And one of the issues you can have is as the ullage decreases, so you've got less and less free space above the liquid, adding less liquid causes a bigger change in gas volume at the top of the tank, which means it can pressurize quicker. So if you do really basic single valve bang bang control, pressurization control, where you just have one inlet valve that you're opening and closing, You'd probably also have a vent valve to knock the pressure back down if it does get too high. But if you've got one valve for filling, you are going to either be waiting forever to pressurize your tank and fill your tank, or you run the risk of, as it gets full, you can lose good quality control of the pressure of the tank, because you're going to open the valve really quickly, but it's going to increase the pressure more than you want to. So a lot of times there'll be a manifold with multiple valves that have different flow rates, just based on how big their opening is, how big the tubing they're connected to is. Maybe there's some orifices or something else that restricts the flow. But this is something that gets used in a handful of places. So let's take a look at what I've come up with. Let's not look at the config yet. So we're going to run, it says DACMX test app. This is kind of just my catch-all, configure a whole bunch of stuff and test it out. And then I've got my test GUI app. So there's still all sorts of fun stuff in here. Config monitor, I can check the status of all of the configs across the test system. Debug GUI, this tells me what the module hierarchy looks like. And this even works across targets or applications. So I can see the DACMX test application has all of this stuff running. We can see the analog input, digital output, all of that, including the digital control. We can see all the data processors and loggers. And then the GUI application. And if I open the GUI, we can now see that the GUI is there running along with its GUI helper. If I close the GUI, it is now stopped. There was metrics reporting in here, but that ate up too much performance on C-RIOs, so it is currently disabled. Event viewer, this is the log for everything happening in the system. And then a bunch of generic GUIs. So there's a whole bunch of DACMX stuff simulated in this, using simulated CDAC chassis and Macs, but just a whole bunch of channels, including some that are doing really weird things. Interesting. I haven't looked at that since I've configured this I/O. But yeah, a whole bunch of stuff for basically an equivalent setup of one of the systems I have at work that I'm responsible for. System status, we could see if there were multiple GUIs running, this would show all of the different ones that are running, TCP server, like all the different clients that connect to the messaging server. But anyway, we're here for Bang Bang with Ullage control. I don't know why that keeps turning on. I do have to, there's a couple of things I have to clean up. But yeah, so I've got a handful of things happening here. So we've got some pressure transducers, and redundancy is good, and fail-safes are good. So we'll see that the pressure transducer simulations I've got here, which is just sliders that I can change the value of, as well as some level sensors. So let's say, I don't know what a realistic level is on a tank, but 400 units of whatever, inches, I don't know. But some kind of fill level on a tank, and then its pressurization pressure. And then I just pick some random numbers to demonstrate this. In fact, I'm going to exaggerate this. So we're going to go an upper limit of 800 and a lower limit of 400 for the Bang Bang. And the idea of the Bang Bang is if we're below the low limit, we turn on and we fill till we hit the upper limit. It's going to then presumably decrease because some commodity is getting consumed or venting or whatever the case might be, leaks. So it'll slowly go back down. And once it gets back down to the low limit, it'll increase back up to the high limit. And then if it does hold tight, it'll just sit in the middle, and we won't be opening or closing valves or anything like that. But we'll make it really wide so we can exaggerate the control here. Now, the other thing that's happening is there are 3 of these, and they're in a voting triple that it does a median choice on. So whichever value is in the middle of these 3, it's going to take that as the single value for this triple. So for simulating this, and it could be any one of them in any order, as long as whichever one's in the middle, that's going to be the one it picks. So I can't move all 3 at once. So I'm just going to set 1 to be max, 1 to be min, and then this will be the one I play with. And it's transmitting as telemetry that voted process value. This is real nice because you can have one pressure transducer kind of just go off and do its own thing, or a line gets cut or whatever. Some PTs can fail at cryo temps unexpectedly, but the redundancy is nice because you could still get, as long as two of them are within range, you still get decent values. And you don't immediately lose sight of what your system is doing. And then something very similar here on the right side. So this is just another median pair, triple, not pair. And then a whole bunch of parameters and valves. So these are valves. I can manually operate them. Obviously, this is simulated I/O. They're not hooked up to anything. But the idea is that these are still controllable manually. I don't have these GUI elements disabled. But I can also just turn on the discrete fill. And so this is going to choose which valves to use, what valve combinations to use based on this Ullage process value. And in fact, I just accidentally did it. If you go too high, which I have set at, I believe, 350, there's another set of ranges that I don't have on the GUI. But if I go above 330 is what it was, that's right, it'll actually disable itself just as a failsafe. Maybe that's what you want, maybe not. It's configurable, but if it does go too high, it'll turn itself off. Presumably, that would usually only happen if there's a stuck valve, which turning off the control won't really do much. That's when you always have a vent and relief valves and maybe an e-stop. But yeah, and then there's the bang bang. So bang bang, turn it on. We're below the low limit, so it's going to turn on, and we can see that it turned on this Ullage fill, this discrete range control, the same way I would have done manually, just by doing it, behind the scenes. And these will still, this is doing its own thing. It's just that it's getting turned on and off by this bang bang. So if we go super low, and let's say the pressure gets up to that 800, the fill turns off, the valve's closed, and it's going to take until it gets below the lower limit. It'll turn back on. And then, wherever that Ullage ends up getting, even if the Ullage changes while it's off, when it turns back on, it'll be in that correct range. Now, I have all of these parameters broken out here in the GUI. They're just showing the default values that come from the config. And we can see there's actually 5 ranges I've got here. I've got kind of like an abort low and an abort high. There is also an explicit abort configuration. So if it ever falls out of the specified ranges, it'll do this abort behavior, which is basically going to turn off the bang bang. So we've got the bang bang control element here, and this is going to just turn that off. It'll also turn off all of the valves that it's controlling. So going through this configuration, and I'm going to cover the bang bang as well. So this guy, this entire object here represents a channel value in this telemetered commandable setup I've got. So it's going to have the meta that calls it out as a channel data type for the configuration. And then this is all in this digital control task, which is running at 100 hertz for logging. It's going to split log files every 1 gigabyte. And then it gets into the control groups, which this is the telemetry group. So one of the ideas with this framework is that a whole bunch of values get published together, everything that's going to be running at the same rate. So things in a single AI task, things in a digital output task, things in a control task that's iterating at a given rate. All of those values are typically getting updated together, so we'll just be efficient and transmit them all as a group. And then we just need to send the group name and all of the channels that are in it. There's some debugging channel values here, what the last delta time was, and if the last period was late. These also get logged. Anything that's channel in something that has logging enabled will get logged when logging is turned on as well. So you could go back and check that at whatever the actual rate is, since things typically only get published out on the network as telemetry at 10 hertz. Then we get into the controls. So we've got the fill bang bang. So it's a bang bang control type. And then this is the only thing this type is the only thing that the digital control module cares about. And then it does a lookup from that string that maps to a class. And then that class knows how to read the rest of this config. So it's going to look for what is the output channel. So in this case, the output channel is this other control element. And then there's the process value calculation object. And so this is some nested configuration that gets passed into a helper class that kind of cleans up when we need to do this kind of voting. There's median, there's average, there's min, there's max. And so that's pretty easy to expand on. There's a process value. So this is a channel that is meant to have the output of this process value calculation shoved into and published as telemetry on the network. This is useful for helping you figure out which of the PTs it's actually choosing or averaging, or whatever the actual value that it's operating on. Now, all channels have to have unique names in an entire system. So we've got another meta field that is used for searching and identifying specific things. So this is a parameter name that can be repeated. So we look up this to know what this name is, because this name is going to be different anywhere it gets used. We can't repeat channel names. Bunch of other options for changing the behavior of bang bang. I won't get into all of them. And then the upper and lower control range parameters are also channels. Have to do the same meta value lookup, because these names always need to be unique. And these are just the defaults when the system starts up. But as we could see in the GUI, I could change these. And that, again, that's because these are channels, they're commandable. Also, it's because the digital control module implements the command handling for channels. So that makes them commandable the same exact way an analog output would be, the same exact way. This guy, instead of controlling a single valve, can control another digital control component. Kind of some similar stuff going on in the discrete range control. So this is just have a process value, and there could be 1, 2, 3, 4, 5 values in here. You could just have a single value. If you did only have a single value, you could even just do the single string itself. It is able to figure out what the data type is from the config, and it will handle it mostly appropriately. You can get some weird behavior if you combine some calcs that aren't, all of the calcs that are implemented would work fine, but I'm sure at some point could cause some weird behavior. And then we've got the outputs. So the whole idea of this discrete range is that we've got a handful of outputs that we want to do some kind of control mixing on. So that's what these are. And these come from these simulated variables. So doesn't matter if they're inputs, outputs. It does whatever task they're part of, should be able to accept commands on them, which, of course, the simulated, the sim values, the software variables, is implemented to do that. But so it's just going to some dummy values in memory. And then configuration for when this control component gets disabled, what is it going to set the outputs to? So these are always before scaling for the electrical units. So the way I've been doing everything in this is true is open for a valve, true is flow, connected, whatever, and false is closed, no flow. If these did need to get inverted for, say, normally open valves, which we often do for vent valves, there would be some scaling configuration, which, yeah, there's different types of scaling configuration that could be applied, one of which is invert bool. And where was I? So yeah, so this is, it's going to set, and then these are just arrays. This was actually one of the things that I had to fix to get this working properly, was making sure the array elements maintain their ordering properly in my configuration library. But so this first false would correspond to this element, this to the middle, and to the last one. And then we've got the abort configuration. I talked about that a little bit. We're going to turn the bang bang off This will, if abort is configured, you could omit this section completely, and it just wouldn't automatically do anything. It would just stick with whatever either the first lowest range is or the highest range, depending on if it goes past one of the ends. But yeah, we want to turn off the bang bang so that if pressure still fluctuating, it's not trying to turn this back on. Because if we've gotten out of one of these configured ranges, there's issues. And just make sure all the valves are closed. There's a process value telemetry channel. Again, just make sure we can see what the result of this process value selection is. And then the configured ranges. Now this is an array. This order does matter. It does need to go from low to high. But for each one of them, you specify a range and then what the outputs are going to be for that range. So I kind of just went from all three of them on to just mid and low and then just low. But you could have as many ranges as you needed for whatever combinations you want. And then again, these are just the default values when it's first run, and those could be changed during runtime. If you change them during runtime and then restart the software, they will go back to their defaults. And that's if you restart whatever DAC system you're running the control portion on. You can close and reopen the GUI and things maintain their state. So yeah, that is this example of doing an Ullage aware fill. But of course, this is more configurable, more universal. So this discrete range control could serve for more use cases than just this Ullage aware fill. And it can get used by itself. It can get combined with other automation elements and kind of use these Lego blocks to build up some more complex functionality. But yeah, so thanks again for that idea. This was fun to get built. And yeah, if there's any other questions, let me know.